has facilities supported a more functional style of programming. So we've got this defined, and let's run it 6 times. So get a new thing, and we'll do countdown from 6, and hopefully I didn't make any mistakes while printing that, and we'll run it. So here we go. So what did it do? Well, I put in 6, right? And it stepped through. Is 6 less than 1? Nope. Goes to the else. Well, it prints f, n to go, 6 to go, and then it passes n minus 1 back to itself. So it passes 5 back to itself, back up to the top. It's a loop, but nowhere did I write while. I didn't write a for. It's just looping because it's calling itself again and again. So if we count down, 5, then pass in 4, then pass in 3, 2, 1, and then finally pass in 0 into there, and it says, oh, we're all done.
What is n here?
What's that?
What is n? It's n.
N is the argument. Okay.
You
Yes.
pass it
Let's
Okay,
actually.
got it.
Yeah. But you pointed out an important thing, which is I didn't put in the documentation.
I thought we are entering a random number.
Counts down from the the argument n passed in, printing a message there. Now we've maintained we've maintained sort of good code quality standards. There it is. We've got a nice little message there telling us what it does. And it tells us what n is, right? N is our passed in argument. And right now I don't have it constrained to integers. I mean, ideally we would constrain it, but it's good enough for now. The important point is that it demonstrates recursion. Now, what if we wanted to count up, right? Why did I get that? What if I wanted to count up to 10, to like 6, or count up to 10, but I wanted to write it recursively? I could write it easily with a for loop, counting upwards, right? But what if I wanted to write it recursively, counting upwards? So we're going to put in some markdown, and let's put in some markdown, and I'm going to call this recursive functions. Just copy this, just to format the workbook nicely. There we go. So, this function will count down. Period. Now, I need some markdown, and I'm going to call this factory functions. And I'm going to slide this down. Factory functions. How do we make a recursive function count up? We have a couple of choices. First, we could use 2 arguments. One for the current count, and one for the final goal. Or we could use a protected global in a factory function. So factory functions could be named anything. Factory functions are just functions that return other functions. they define a new global scope for the return function, so that the same call to a function can produce different results. All right. So I'm going to just use the word factory. I can use any word I want. What we're going to do is we're going to make a function that makes another function. So I'm going to say def factory, and it takes no arguments. Oops, I need that, change that to code. So this takes no arguments. It just return. Oh, let me think of this. Yes, it takes no arguments. It simply returns returns a function that counts up. Will return a function that recursively counts up. So the critical part is it is the job of the factory function to keep track of the engine's progress in reaching a goal. So I'm going to create a variable called progress, and I'm going to assign it none right now. Actually, I'll just declare it like this. No. Yes, I have to assign it none now. Okay, and I'm going to define my factory function. So I'm going to put in this is the actual count up. I can make this 0 actually. This is the actual count up recursive function. And starting from 1, count up to the passed in argument n. And I'm going to take this out because I already have that def on def engine and put n in here and this, and then I have to just indent this. All right, so I've got, this is demonstrating two things. The first thing it's demonstrating is a function defined inside a function, which we'll use. And then we're going to demonstrate returning that function. So when we're all done, we want to return the engine. Notice I didn't put a value or braces here. So this is send out the engine that was built to be used. No arguments provided. Right? The arguments get provided later on. So what is engine going to do? Well, it's going to update progress. So we'll start with progress, and there's a special way of updating. a little shorthand. This, that little plus equal, plus and the equal sign is called the increment operator, and it's saying increment by 1. So this is exactly the same as saying progress plus 1. We can do that, or we can simply say increment. Oh, wait. Forgot one special thing, non-local progress. So what does this do? This gives us access to the variable progress defined in the outer scope. All right, so what's going on here? If I just had progress without the non-local there, then this would create a whole new progress variable only inside of engine. But what this does, it says, oh, I want access to this guy out here, because this guy is going to keep track of what's happening. So I'm going to do that, and then I'm going to update the progress, and then I'm going to check the progress versus n. So what I will do is if progress is less than n, then print that string, and I'll say put the number in for progress, and I will write the words so far. And then I'll call engine again. Engine with the same n again, because the n is the end goal. In fact, let's change it this. We'll change this to goal. Control C. V, change that to goal. And goal. And change this to goal. Goal. There we go. Now, otherwise, what do we do if it's reached our goal? Then we just simply print all done. Like this. And we will save this. Now this, this looks a bit more complicated than just writing a for loop, and it is. It's a contrived example of using a factory function. But the important part is that it will go through and it demonstrates the idea that the factory function keeps track of the progress that the engine function is doing. So I'll say test if we have reached the goal, otherwise keep going. Right, so I don't need the return at the end here because it's superfluous. They simply reach the end of the function. So I'm going to hit, and that compiled just fine. Now to use this, what we have to do is first we create an instance of the countdown. So we say countdown equals factory, like this. Then we use the function. And I'm going to put in a little print here. I'm going to say print, and we'll check the type. What is the type of countdown? We'll do countdown to 6. Or, sorry, I want this to be count up. Count up. Control C, Control V. There we go. here we go. Hit play. So I counted up to, look at that. That's actually perfect. I just caught myself off guard. So, what happened here? Well, I called the factory function, and the factory function returned the engine function. So the function returned a function, right? So the engine function got returned, and I can do that. I can check that. I printed the type of count up, and it says, hey, you returned a function. And then I want to do something with that function. I want to count up. And so I said count up to 6. And what happened is, this is the really tricky bit. When it counted up to 6, it updated the progress variable that's outside of it, that's stored in the factory. So what happened is it updates progress, which is stored out here, and then prints so far, then goes around and runs again, increments progress by 1 more. So progress, initially progress is 0, then it gets turned into 1, goes around 2, 3, 4. Now the tricky bit is, progress is currently 6, right? So if I call count again, let's do code. So if I call count up again, and I put in something like, if I put in something like 3, will that work? 3 is less than the progress so far. If I run this, it'll just say all done. And it just says all done. Now if I set this to 20, let's see what it'll do. It'll start at 6. It'll start at 7 or 8. It went. Sorry, it stepped through once already. So it started at 8. If I run this again and try to start it at, and if I run this again and do like 32, it'll start. Where do you think it'll start from? So so let's just see. So I'm gonna call count up from 32. I need to put these people on mute. I'm gonna call count up from 32, and let's run what it does. I started at 21, right? Because that was the last value of progress recorded in the factory function. Now, if I wanted to reset everything, then what I would do is I would simply call factory again, equals factory. Run this, and oops, no, I'll do it this way. And I'll do count up to 7. And now it reset. But it counted up to 7, which means the progress hidden inside a factory is at 7. So if I call count up to count up to 18, so I say count up to 18, it's going to remember that I was at 7. So count it up to 18, and at 18 it said all done. So it's a tricky little bit of programming. The critical thing is that if you define a function inside of another function, the outer function's variables, to access them, you need to write in the word non-local, right? The whole crux of this thing, the reason why it behaves the way it does, is because we've specified this non-local here. If we didn't have this non-local here, then progress would just get reset every time progress would just be reset every time the function calls, and we would be stuck in an infinite loop, and it would just go over and over again, because progress would always have the value of 1. It would never increment. It's because progress is defined outside of this function that it's keeping track of where it's going. That's a mind bender. Any questions about it so
Like,
far?
The scope is limited to that function only, not
That's
in the
right.
nested function, that's
That's
why
right.
we use the non-local.
Non-local gives it access to outer scope.
Okay, got it.
Yeah. And so I've written the, that's why I've got the. this-
Otherwise it will behave a new,
It
kind
will
of
end up
new
in an
variable.
infinite loop, yeah.
It will behave as a new variable.
Yeah,
That will
that's
not
right.
use. Okay.
That's exactly it. Okay, so we've made some progress, and I think we're ready to tackle the game. So we're going to define our game. Def game. Not taking any variables because it's a fixed game, and this is 2, 3. Oops, I always do that. And we'll just say the classic Monty Hall game using text inputs. Returns, we're going to return the final tabulations of returns a cross tabulation of wins and losses by choice of swap versus stay. So what are we going to return? We'll return which way did I do this? I did swap first, yes. So we'll return the swap wins, then we'll return the swap losses, then we'll return the stay wins, and then we'll return the stay losses. And I'm just going to, because this actually accepts markdown properly, I'm going to put all this in like this. And there we go. All right. So I need to define these, or I need to give a little written explanation. Number of wins after switching doors. Number of losses after switching doors. Number of wins after keeping the choice. And number of losses after keeping the choice. All right. So I've got some variables there that I want to return. So let's just define them. Here we go. Oops. Control Z. Control V. So we've got our initial variables there, and at the very end. So these are our. I'm going to say these cross tabulations of results. And at the very end, we're going to send the results. And I'm just going to copy the return statement. There we go. So everything else we need to fill in the middle. And we're going to do this by making a little game engine in the middle that just calls itself. So we're going to have, and we'll just define that. We're going to say def engine, but we're not going to return the engine. We're just going to have an engine there. Def engine, and let's document our engine. We're going to say it's our recursive game engine that runs until until exit is chosen. All right. Now, we need to know how, well, one of the things we need to do is we need to make sure it can access the cross tabulations. Okay, so how do we do that? Well, we've got our non-local. So get access to the cross tabulations to track between individual games. So we're going to copy all of these. Control C, Control V. I'm going to tab these in. I'm going to type in non-local, and I'm going to get rid of the equal signs. Non-local. And that. Just copy this to make it go quickly. Control C, Control V, Control V, Control V. So that gives us access. That gives us access to the variables. So that's one side of this function. And I like to sandwich my functions in. I like to start at the beginning and the ends and then work towards middle. So we need to be able to prompt to continue. So we need a prompt to say, do they want to continue? And sure, our prompt to continue will be again. Now, if they want to play again, so if again equals yes, oops, and I need double equals like this. If they want to play again, then we just call the engine again. And that's it. So that's our recursion. Right? That's our looping back to the beginning. Now I do need to put in a little bit there to sort of clean up the code, right? Because I need to make sure that they type yes or no instead of random, instead of anything random. But what we can do is instead of checking yes or no, we can simply say anything other than yes is we'll just say anything other than yes lets them quit the game. So, and because we put this at the very end, we don't need a return statement on this inner engine. It's simply going to quit as soon as they reach this condition. Now, what's the critical thing on each instance of the game is to choose a random door. So I can define a non-local. I can define a set of doors. And this is a special notation. This is our the doors as a Python set. There we go. And I need to be able to access that. So I'm gonna again put this in as non-local, and I get access to the doors. Okay, so what is special about sets? Notice the notation, it looks almost like a dictionary, except it doesn't have the colons, it's not a key value, it's just a single value. The thing about sets is every element in a set, every item, has to be distinct. So if I try to add 2 into this again, it won't change anything. It only adds things that aren't in it already, which is really useful when you want to take, like if I've chosen door 1 and I want to know what doors I can still work with, then I can just do a set difference, and I can say what's the difference of doors versus versus the union of what we've chosen and where the actual door is. So that's the main thing, and and we're just, the reason why we're defining it as kind of a global is it'll act as a constant. We've capitalized it to indicate that it's going to be a constant, but we give access to it. There's a small efficiency gain doing it this way as opposed to redefining doors every time. Not important for a game this small, but if you were doing something with something really big, where if this was like a really big data frame that you were doing some processing on, you would want to define this just once and then let that go. And data frames, we're going to cover that before we cover object-oriented programming, because we're going to cover data frames as a method of managing large data sets. And data frames are basically Excel spreadsheets, but for Python. So they have columns and rows and things like that. So we've got our choice of doors. We now need to choose one of them. So let's put the prize behind a door. Put a prize randomly behind a door. So we'll use the random function, and I'm going to just create a variable called prize that indicates where it is this time. So the idea is every time we run through a loop of this engine, we randomly reassign the prize, right? Change it to a different door. So we say prize random.choice, and the tricky bit is choice wants a list and not a set. So I have to put in a list, and I have to say, hey, turn my doors into a list. What does this do? Well, let's just take a look at what that notation does. So let's make a set, A, and we'll put in 1, 2, and 3. We'll print A. We'll print A, let's do F. F, and I'm just going to print A uncompressed like this, and then I'm going to print A turned into a list. So let's type in chicken. Oh, okay, that's fine. And finally, I'll see what this does. Let's see if this unpacks it. All right. Sorry, I just wanted. All right. So, what does this demonstrate about sets and converting between lists and sets? A is a set. If I print A, it just sort of prints out what we had. If I print A star, or the star operator on A, what did it do? Well, it's the same. What it did here is the same as if. Let's do a second print here, so you can see that's the same as if I went 1, 2, 3. So hitting this is the expansion operator. It expands it into its individual elements and passes it as individual arguments, and so we can see that it produces identical results. Finally, if I put it in square brackets, it turns it into a list. So what we've done here is we've taken our set, doors, and we've turned it into a list, and we've said make a random choice from those 3 doors, right? And that's where our prize is. Now that we have the door chosen, we need to prompt the user to choose a door. And we know how to do this. This is just our old prompt, which is, I'll make it the first choice of door. All right. So we're prompting them. We're saying, hey, choose door 1, 2, or 3 to choose a door. And what we'll do is we'll say if it's not 1, 2, or 3, then exit. And we'll just do that with a simple if statement. So we'll say if yes, if first is not in our doors, right? So we're saying, hey, if they haven't chosen something in our set of doors, then just return. We'll just leave. Right? We won't update anything. We won't update the cross tabulations or anything like that. We'll just return. Right? We'll take anything. We'll take any input other than 1, 2, or 3 as an exit choice because it just makes it easier to work with. Next, we need to select a door to reveal. Now we could belabor this with a long if statement, or we can do a little shortcut here. So where are we? We are, there we go. So to do this, we want to randomly select from the set of doors that are neither have the prize nor selected by the user. So we can do this by making a set of the prize and the user's first choice and removing those from all the doors. So the way we can do this is we've got doors and there's a special function here called remove. And what we need to do is we need to remove a set. So we need a set here, like this, and the set is the prize door and the first choice door. Now the neat thing about this, let's test what happens when we create a set with 2 elements that are the same. So we already saw that we can create a set with different elements, but what happens if I happen to say 2, 2? What will this be? Oh, perfect. It actually figures it out and makes it a set with just 1 element. So this is the nice little miracle of sets. If I put in the same value, no matter how many times I put in the same value, it collapses it all down and says, oh, you just meant 2. Which is really nice because it means if the user has selected the prize door, right? So I've got the user first selection and the actual prize door, it's going to collapse down to a set with just 1 element. And then the difference, then we'll use the difference to take that away. So, oh wait, that's remove. I want difference. So if I highlight over difference, return the difference of 2 or more sets as a new set. Perfect. i.e., all the elements that are in this set but are not in the other sets. So what's this going to do? This is the set of all doors. Take away the prize door and take away the user's first choice. And from that, I want to make a random selection. So to make a random selection, I need to use RD random choice again. I need to turn it back into a list, and I need to close all my brackets properly because it's highlighting stuff in red. Oops. So, and just to recall, RD, where did RD come from? It's the library I imported. Way up here. This is way up here. Let go. Sorry, my mouse wasn't letting go. I did an initial import, and I imported the random library as RD. So sometimes you just kind of lose track of those things. All right. So I need to do something with that choice, and I'm going to call it the variable reveal. I'm going to say this is what we will reveal. And now I need to prompt the user to stay or swap with the additional information.
The price will be between 1 to 3, sir.
What will be reveal?
What will be the price? Like,
The price is random on every time it runs.
It will be 1 to.
It'll be behind one of the doors, 1, 2, or 3.
Okay.
So it's only behind one of the doors. So we need to create another input prompt, and I believe I wrote this as I said stay was yes. Okay. Stay equals, and stay is going to be the output of an input. So input, and I'm going to say, I'm going to make it an F string, a format string again. Format. The prize is not behind door reveal. And I'm going to make this a bit of a longer string because I'm gonna help the user out so they don't have to remember what they chose. So I'm going to add another F string. I'm going to say F. You initially, your first choice was door, and I'm going to say first, period. And finally, I'm going to prompt them as, I don't need that as a format string. Type yes to stay with this choice. If they type anything other than yes, it will swap the choice. There we go. All right. And do I need to check stay is no? Nope, I don't. Perfect. That will work well. All right. So now I've got whether or not they want to stay. If they type yes, then they want to stay. If they type anything else, they don't want to stay with that choice. So now I need to do something with that, right? So I've got their first choice. I've got the door that is behind. I've got the and I've got their choice of swapping. So now we just need to run through the possibilities. So now we need to update the cross tabulation based on the choices. So the first possibility is if they decided to stay and the prize door is equal to their first choice, what happens then, right? So they've just, the prize happened, their first choice happened to be the correct door, and they've decided to stay after being given a prompt. They win, right? So then we update, we say stay wins, gets incremented by 1, and we print win, right? The next thing, so how can this fail, right? how can this not be true? Well, either they could have chosen stay as no, or the prize is not equal to the, or their first choice is not equal to the prize. So if we check the next L-if as stay equals yes, then the only way they can get to that next L-if is if the prize is not equal to the, is not equal to the, the prize is not equal to the first choice. All right, so in this case, they chose to stay, but the first choice was not the prize door. They lost. So we,
Stay lost.
yep, stay losses gets incremented by 1. Now, the other possibility is if they, the other way that, so what are the possibilities that left for this to be false? Well, they could have said, stay is equal to, oh, they could have had the prize is equal to the first door, but they chose to swap. So,
I'm not getting this game, sir. Like, what is stay losses? Like, the number of time we are entering the wrong digit.
that's right.
Okay.
That's right, right? So we're keeping track, we're playing this gambling game multiple times, and we're keeping track of how many times we win and lose in this gambling game, contingent on the.
First not equal to the random number.
That's right. So in this case, our first choice was correct, but to get to this point, we had to have chosen anything other than stay. We had to choose to swap our choice, which means we got it wrong. So this is swap losses. So this is swap losses plus equals 1. And we're almost done. Everything else falls nicely into swap wins plus equals 1. And that should be it. Oh, and a full call. That should be it for the whole algorithm. I'm just gonna go down here and make sure that it matches what I worked on this morning. Yeah, I've actually simplified quite a bit of what I did this morning. All right. So now we just need to run this in the interpreter. Say, oh, make it a function. Let's make sure it didn't have any errors in it. No errors in it. And we'll add a code cell, and we'll actually just try running the game. Let's see what happens. So, why did it not? Oh, I know why. I didn't call. I didn't initialize the game. So I define the game, and then I call it once. Oops. So we need to initialize